Hi guys, and welcome to your 9-3 notes. Today we will be solving multiplication and division inequalities. By the end of the day, you will be able to solve inequalities involving multiplication and division. Now yesterday, we solved inequalities with addition and with subtraction. And you'll remember that to solve an inequality for a variable, you have to undo what is happening to it. For example, in number 1, we have this variable m, and what's happening to m? Well, we have a plus 7. So to undo a plus 7, we're going to minus 7. We have to minus 7 from both sides, and that will give us that m is less than or equal to 5. In number 2, if we want to solve negative 9 plus n is greater than negative 12, we have this negative 9 adding to our n. So to undo negative 9, we're going to add 9 to both sides. That will give us n is greater than negative 3. A similar thing happens with number 3. Here, instead of adding or subtracting, we see that we have 9 times g. So to undo times, that's going to divide. So we divide by 9 on both sides. And that gives us g is less than or equal to 3. And then finally on number 4, we have 7 is less than h divided by 3. What's happening to our h? Well, that's a divide by 3. So to undo divide by 3, we need to times by 3. That'll give us 27, not 27, just kidding. That'll give us 21 as less than, and then this divide by 3 times 3, those cancel out. 21 is less than h. So all we're doing is we're undoing what's happening to our variable. Now remember, in case you need extra time, you can always pause our video, or you can rewind it if you need to revisit an idea. So, let's say you want to solve the equation 4x equals 36. Well, to solve this equation, our first step is to undo this 4 times. So we're going to divide by 4 on both sides. That will give us x equals 9. Now, what if this is an inequality? We can still do the same thing. Instead of 4x equals 36, if we have 4 is less than 36, well, first of all, that's true, right? That's a true statement. And if we divide by 4 on both sides, we get 1 is less than 9. That is still true. So when we divide by a negative number, we still have a true statement. Yay! But what happens if we have negative 4 is less than 36, and we divide by negative 4 on both sides? Well, negative 4 divided by negative 4, that's 1. It's less than. 36 divided by negative 4 is negative 9. Because we had this dividing by a negative number, it now gives us a false statement. Because last time I checked, 1 is not less than negative 9. Oh no. So everything was going as expected until we threw a negative number. So our key idea for the day is when you solve an inequality and you multiply or divide by a negative number, we have to do a special trick. What we're going to do is we are going to flip the inequality symbol. Symbol with a Y. We're going to flip that inequality symbol. So let's do a bunch of examples. Here we have negative b is greater than or equal to 4.7. Now we want to undo this negative 1 times b. So to do that, we're going to divide by negative 1 and divide by negative 1. But notice, we are dividing by a negative number. So when we do that, we need to flip our sign. Let's flip our sign first. This greater than or equal to becomes a less than or equal to. Now negative b divided by negative 1 is b. 4.1 divided by negative 1 is negative 4.7. Let's go ahead and check our work with what's a number less than negative 4.7. How about negative 5? So let's check with negative 5. Is it true that negative 5 is greater than or equal to 4.7? Well, 5 is greater than or equal to 4.7, so yes, this is true. Awesome. Now let's graph our number line. So we're going to graph with negative 4.7. We can do negative 5 and negative 4. Sure, why not? And now we have is greater than or equal to, so that's going to give us a solid circle. We already checked negative 5, and we know that negative 5 works. So we're going to go towards our negative 5. Next, we have number 6 is 3/4 times c is less than negative 2. To undo this 3/4 times, we could divide by 3/4, but dividing by fractions is hard. And the same thing as dividing by a fraction is we're just going to multiply it by the reciprocal. So we're going to flip our fraction upside down so that this 4/3 is going to cancel out with our 3/4. So we multiply by 4/3. And notice we are not multiplying by a negative number, so we don't have to flip our sign. Our sign is going to remain the same. So 4 and 4 are going to cancel out, 3 and 3 cancel out, giving us just c is less than, this is the same thing as negative 2 over 1 times 4 over 3. So c is less than negative 8/3. And that's it. Now let's check our work. We need something less than negative 8/3. How about negative 9? So we're going to check with negative 9. Is it true that 3/4 of negative 9, that's a bad example. Let's not check with negative 9. Let's check with negative 8. Negative 8 is certainly less than negative 8/3. So is it true that 3/4 of negative 8 is less than negative 2? Again, we're checking by plugging into our original equation up here, original inequality up here. Well, 3/4 of negative 8 is negative 6, and negative 6 is less than negative 2. So that works. Now we're going to graph our solution on a number line. So we'll put negative 8/3 here. Negative 8/3 is the same thing as negative 2 and 2/3. So we can graph with negative 3, negative 2. Now it's also an open circle because there's no less than or equal to. Now we already checked that negative 8 works, so we're going to take our number line, point it down to negative 8. Number 7, we got negative 8a is greater than 40. Now what's happening to our a? Well, it's multiplied by negative 8. So to undo that, we're going to divide by negative 8 on both sides. And you'll also notice we are dividing by a negative number. So to divide by a negative number, we need to flip our sign around. That's going to become a less than symbol. So these 8's cancel out. We get a is less than negative 5. Let's check our work. What's the number less than negative 5? How about negative 10? Let's check with negative 10. So we're going to plug it back into our original inequality. Is it true that negative 8 times negative 10 is greater than, is greater than 40? Well, 80 is greater than 40, so yes, that's true. Let's go ahead and plug that into our graph. We solved that 8 is less than negative 5, so we'll put negative 5 here, negative 6, negative 4, and it's not equal to, so we have an open circle, and we know that negative 10 works, so we're going to draw our graph down towards negative 10. Our last example in this group is 7 is greater than negative d over 2. Well, what's happening to our d? It's dividing by negative 2. So to undo that, we're going to multiply by negative 2. multiply by -2 on both sides. And since we are multiplying by a negative number, we need to flip our symbol around. So in flipping our symbol from a greater than, we get a less than. And 7 times -2 is -14. D divided by -2 times -2 is just D. Let's check our work. What's something greater than -14? Well, -14 is less than 0. I like 0. Let's go ahead and plug in 0 and see if that works. So 7 is greater than -0 over 2. Is 7 greater than 0? Yes, it is. So let's go ahead and graph our inequality of -14 is less than D. We'll start with -14, -15, -13, and it's a strict less than, so we have an open circle, and we already checked that 0 works, so we want our graph pointing towards 0. For our last activity, we're going to stick right on pace with Nick. Now, what we're going to do is we're going to read our word problem, then we're going to translate it into math, and then we'll write our inequality and answer a question. So while training for lacrosse, Nick runs at least 12 miles every day. If he runs at an average pace of 6 miles per hour, how much time does he spend running every day? Well, how much time does he spend? That's going to answer our question. So if we ask how much time, we're going to want to answer that with time. So let's go ahead and put T for time. That also tells us that our answer, how much time, spends at least whatever running every day, that's going to be a time answer. Okay, now Nick runs at least 12 miles every day. At least 12, that tells us that his distance spent running is at least 12. So that tells us that our distance is at least 12. It could be more than 12, but a minimum of 12. If he runs at an average pace of 6 miles per hour, well, a pace of 6 miles per hour, that tells us that that is his rate. Pace of 6 miles per hour is how fast he's running. So we know his rate is 6. How much time does he spend running every day? Now we have this hint here that rate is time, rate times time equals distance. So our rate times time equals distance. Now that we have everything translated into math, let's plug in the information that we know and see what we can find out. So we know his rate is 6. We know his time is what we want to find, so we'll just leave that as T. And we know his distance, oops, I wrote too soon. We know his distance is at least 12. So we're going to say his distance is at least 12. Now we have our inequality symbol and our inequality written out. So let's go ahead and solve this. Right now I see that we have a 6 times T. So to undo that, we are going to divide by 6 on both sides. Divide by 6, divide by 6. That gives us that T is greater than or equal to 2. Now since his rate was in miles per hour, this is 2 hours. So that tells us that Nick spends at least 2 hours running every day. Good job, Nick. Way to stick with it. So today we learned 2 key ideas. The first key idea is that to solve an inequality, you must undo what is happening to your variable, like how we divided by 6 because we had to times 6. Now we also learned that if you multiply or you divide by a negative number, we need to flip our symbol around. So we are flipping out and we are undoing what's happening to our variable. I hope you enjoy your homework today.